friends. Welcome to Enlightning. I'm so glad you joined us today. I'm here with Stefan, who's going to teach us all about Flagger. Stefan, will you introduce yourself, please?
Hi, everyone. I'm very happy to be here. Thank you for the invite. I'm Stefan Prodan. I'm a software engineer involved in open source in the last 8 years. I've been working on Flux, Flagger, and other projects into CNCF. Yes, I'm very happy to tell you all about Flagger today.
So you're a maintainer of Flux and Flagger. Have you been there since the beginning?
I created Flagger. So next month it will be 8 years
Amazing.
since I started. Let me check. Let me check.
In fact, well,
No, it's 6 years. So I the first commit was on September 2018 on Flagger. For
that's
Flux,
amazing.
and for Flux was predates Flagger. I took it up after a year or two after Flux version 1 was created,
Uh-huh.
and I helped build Flux version 2, which is the current version that everybody uses today.
That's
So
pretty
yeah.
cool. I think you're kind of a legend. We, we also have some friends here. Hello, Kormaju. Thank you so much for coming again today. And hello, Epic Tralala. Good to see you, friend. Let's get started. So to kick off this stream, let's get some context. So what was the world like 6 years ago before Flagger existed that caused you to create it? What?
So I was at KubeCon Copenhagen, I think. Yes, Copenhagen, and Istio was just getting started,
Ah.
and there were many talks of Istio at the beginning, like everything that's new. It's a huge bubble. Everybody wants to hear about it, and I got invited by one of the contributors of Istio to do a demo while he at his talk around how can Istio help with deployments, and I use Flagger, I use Flux in that talk, where basically you would change the routing from one version of the app to the next version by committing to Git. So
Okay.
Istio has this API where you can define where traffic goes inside the cluster, right?
Okay.
So it's a custom resource definition, and that's a YAML file, right? You can put the YAML file in a Git repo, Flux applies it. So the demo was around, I have version 1 running, I deployed version 2, but no one sees it, no one can access it. And then I go into my Git repo and I change the routing, 10% traffic, whatever, to the new version. And that was the demo. Everybody loved it. It basically showcased how awesome was Istio back then with layer 7 routing and so on.
Yeah, there are two things I want to say about your story so far for those who are beginners and watching. One is Istio, although it's a service mesh, it has an ingress component too. So just FYI. And then the other thing is Flux, for those of you who don't know, is a GitOps tool. So just some context to your story. And so everyone was like, hurrah, this is amazing. We're going to use GitOps to be able to change with the traffic and Istio together. Yeah.
So the talk was over, demo went great. Then a bunch of people came to me at the Flux booth, and everybody was saying, like, can we automate this stuff? I mean, I don't want every time I'm deploying a new version to go in Git, do a commit, then wait for the traffic to route. Then what happens if something goes wrong? I have to do another commit, right? And roll back the traffic and stuff like that. Can this be automated? And there was a person there that said, oh, but we can make something like the horizontal pod autoscaler. Horizontal pod autoscaler is dynamic, right? Based on some metrics, it does scaling up or scaling down. Can Flux do that with with traffic.
Uh-huh.
So I would say like, no, this is completely out of scope for Flux. Flux is, it takes the desired state as is specified and makes sure that gets reconciled on the cluster. It's not something that do things dynamically.
Uh-huh.
Went back home in Bucharest. I thought about that, and then I started playing around with building automation on top of Istio.
Uh-huh.
And that's how Flagger came into being. I think the first no, I named it Steerer.
Tiller.
That steerer
Oh,
from
Steeler.
steering
Oh,
from
steering.
steering.
Uh-huh.
Yeah. And Alexis back then, who was the CEO of WeWorks, said to me like, no, this name is too English. It will not work for US people. It's hard to pronounce. Like,
Uh-huh.
we need to think about something else. And that's how we thought about some names. And that's how Flagger was easier to pronounce. And it was about, traffic, right? You flag. Flagger is a traffic thing, right?
Okay.
So it got fast renamed to Flagger. Then I did the first Flagger talk. I did it at the Istio meetup in London. Istio meetup was just getting started back then. I think, yeah, the Monzo Bank hosted it. It was 0.1.
Uh-huh.
I did a demo. Traffic was going forward, going backwards. If the test failed,
Uh-huh.
people were very, very excited about this stuff.
I'm picturing
And
like a KubeCon, like a conference, like standing ovation. People throw their hats in the air. I don't know. It sounds
we
great.
went to the pub. We talked for hours afterwards. Like, oh,
That's
this is
the best.
amazing. You should, yeah. So that's how it all started. Back then, it wasn't this terminology which everybody probably in the CNCF space knows about, and it's called progressive delivery. Progressive
Uh-huh.
delivery. Redmonk, James from Redmonk invented the term, right? Progressive
Uh,
delivery.
and
And
will you define progressive delivery, please?
yeah, it's an umbrella term for advanced rollout deployments.
Okay.
It can mean, switching traffic progressively from one version to another. It can mean
Mm-hmm.
mirroring traffic. It can mean splitting the traffic based on something like a cookie or
Mm-hmm.
whatever else, the
Is
location
it
of the user and so on.
so? Can we say progressive delivery refers to advanced deployment strategies in Kubernetes?
Yes, but it implies traffic shifting or traffic management, which is something that Kubernetes by itself does not provide. That's why.
Uh, uh,
Um,
Maybe not in Kubernetes, but on Kubernetes is a little
yeah,
more accurate. Okay. I hadn't even ever thought to make that distinction before. Okay.
yeah. So Kubernetes, when you install Kubernetes, the first thing you install after you spin up your Kubernetes nodes are CNI plugin, right? That gives you layer for routing. Like you
Mm-hmm.
can link all the nodes there in a network, but it's pure TCP, right? Or UDP if
Yes.
you use something like WeaveNet or other CNIs. But
So just to catch people up, CNI stands for Container Network Interface. And it's basically standardization for how a kubelet assigns an IP address to a pod to make sure that every pod is able to communicate with every other pod in a Kubernetes cluster before you shut it down with network policy, because you don't want every pod to be able to communicate with every other pod. in the end.
Yeah.
Yeah. And
Yeah.
so when we say
So
layer 4, we're talking about OCI layers, which stands for open OSI layers, systems interconnections, right? Yeah.
yeah.
And layer 4, like you just said, is TCP. So you have, it's more performance, but there's less information that you can use for routing or anything else. Yes.
Yes. And in order to dynamically route traffic, you need to identify somehow the user, right? You want, when a user accesses your application, you want to identify that connection. And that type of traffic is called layer 7, which can be HTTP, HTTPS, gRPC. The advantages of having layer 7 inside the cluster is that you can observe the traffic better. For example, you can look at HTTP headers, and based on some information in the header, in the HTTP header, you can take decisions. For example, Flagger implements a deployment strategy called A/B testing. A/B testing is using information from the HTTP headers. That can be a simple header, that can be a cookie. And based on the value specified in the header, it can, instruct STO, linkerd, I don't know, ingress nginx, glue, contour ingress, whatever. Flagger integrates with, I don't know, dozen of technologies. But the idea it's very simple. It's all about HTTP. Basically, you inspect the traffic and you say, oh, if it has location Bucharest, then I want this user to be my, I want to run a test on this user, and I'm going to route the user traffic, that particular user, to the new version of the app. And I'm going to use a segment of the users to test my new version. Another thing that you have yeah.
So we're talking about, we talked a little bit about progressive delivery, and now we're talking about advanced traffic routing, which is part of what makes progressive delivery work. And I'm just trying to think about how to state it simply. So we want L7 routing. So that's what you quickly rattled off a bunch of protocols that qualify as L7. And those protocols are L7 because they contain extra information about the traffic that's being routed. Is that correct? That's what makes L7.
Yeah, you can inspect that traffic and get the metadata out of it, more than just the source IP, which layer 4 allows you to do. So there are a couple of things that are by default in let's say HTTP traffic. The browser user agent, for example. You can say, oh, if I have, assuming you have 80% traffic from mobiles and 20% traffic from desktop, right? You can create an A/B test and say, I want to test the new version on the 20% of my users which are desktop, and you can create in Flagger a rule that says, oh, if the user agent contains whatever, desktop, or does not contain mobile, go to this new version, right? So it's a way to segment the users.
I have some questions, and we have a question in chat too. So let's go to the chats. And in Flagger objects, you specify all of the versions of your app that need to be deployed and transitioned according to the rules that you want. So that way you don't need to change Git for a rollback.
Okay. Now it's different. We are not talking about traffic. We are talking about orchestration. So let's talk a little bit how Flagger orchestrates.
Actually, before you do that, what I would really like to get on the board is a nice definition of what Flagger even is before we dig in too much on all these details about what Flagger does. Does that sound
Okay.
good? So,
Yeah.
Matthias, thank you for your question, and we will get to the answer, but we're going to be a little more structured with how we dole out the information, which is one of the benefits of the Lightboard. It makes us do that. So let's say, so Flagger is, give me at the end of the sentence. Flagger is.
Yeah, I don't want to. I mean, I'm defining Flagger now that people understand what progressive delivery is as a progressive delivery controller for Kubernetes. But
Okay.
I would also say that Flagger is a deployment orchestrator.
Okay. So, so that brings us right back around to Matthias's question about orchestrating different versions of your application.
Yeah. So one thing that sets apart Flagger from all the other implementations that came after Flagger, like cargo rollouts and others, is that Flagger does not replaces the Kubernetes deployment.
Okay.
And why is that? When I started Flagger, people were saying like, we have a deployment in production. We can't take this deployment offline.
Yeah.
We want to all of the sudden implement progressive delivery for it with zero downtime, right? So Flagger does not, using Flagger doesn't imply changing anything to how you set up your deployments. You can still have a Kubernetes deployment in a health chart or however it gets on the cluster. Maybe Flux applies it, maybe Argo applies it, and so on. So Flagger has a custom resource called canary. And you create a canary custom resource that has a reference to the deployment.
It's called Kennedy, Kennedy.
Canary.
Canary. Got it.
Sorry.
Okay, so Flux, I'm going to put that up. Flagger custom resources. Okay, so we have canary. Great.
Yes, so we have a canary, a custom resource that resembles a lot to the horizontal pod autoscaler. So how you define an horizontal pod autoscaler in Kubernetes, right? You have the horizontal pod autoscaler definition, which points to the deployment it needs to scale up and down. The Flagger canary does the same thing. Inside its spec has a target reference where you say, look, do canary deployments for this deployment, and you point out the deployment name. So the canary definition needs to be in the same namespace as the deployment, and then you tell Flagger where the deployment is. You can also tell it where the horizontal pod autoscaler is. And I'll explain later how these to work together.
What I don't understand, so it resembles a horizontal pod autoscaler, but with a horizontal pod autoscaler, we're talking about there's one version of the app and it needs to be bigger or it needs to be smaller. Now, with a canary deployment or any progressive delivery deployment, we have two versions of our app and we're slowly taking traffic from one to the other, right?
Yeah, but to the user is not, there aren't two versions. It's one version. You have a deployment.
To the user, yeah.
So the deployment, the user defines a Kubernetes deployment and a canary definition that points to that deployment.
Okay.
And you apply those on the cluster, right? Or you already have the deployment applied and running on the cluster, and later on you say, hey, I want progressive delivery to, I want to apply progressive delivery from this moment on to the deployment. And you create the canary custom resource that points to the deployment, Once Flagger sees the canary, what it the canary definition, then it starts monitoring the deployment. If you change the deployment at any point in time, what Flagger does is, oh, you want to change the deployment? It creates a clone, a replica of the deployment, which is called in Flagger terms a primary, and that's version 1. So you have your deployment, it creates a snapshot, a clone of it, and everything is prefixed with minus primary. And you have your original deployment and the primary deployment.
So the way in native Kubernetes, when you make a new deployment, it rolls out that deployment across 2 replica sets. It's kind of a little bit similar to that in that it's using one resource, a canary, to manage 2 different deployments. But you're able to do it in a much more fine-grained way because you're using qualities that you've pulled from the metadata to do more advanced traffic routing and fine-grained traffic routing across how the traffic gets from one to the other. Is that correct?
Yes. Yeah, it does routing between the 2. It reads metrics from various metrics provider. It can run end-to-end tests, unit tests, and so on. It's quite a complex thing. But let's explain a little bit the orchestration. So
yeah, I think I want to draw it. I think it's a diagram.
Yeah. So you have the original deployment, the canary custom resource, and then Flagger creates a clone of the original deployment and scales to 0 the one that you control.
So we have a V1 deployment, and our canary resource reference our V1 deployment. And then, and the Flagger controller is watching this canary deployment at the synchronization loop. And so then
it creates a clone of V1 first.
So
this is what it does.
So then, I'm going to write this down. So this is how it starts, and then we do an update to V1. And so then it creates a clone of the V1. Okay.
Yes, and the original one, which is the one that you control, is scaled to 0. Nothing goes there.
Okay.
Right? And it routes all the traffic to the clone of your original deployment.
Okay.
Then you modify your deployment. You say, oh, you change something in a config map that's reference to it, or you change something in a secret, or you change the container version. Whatever you change, Flagger looks for all the references, all the things that make up your deployment. Can be config maps, mounted volumes, can be secrets, can be the deployment itself, containers in that deployment. Anything that changes there, Flagger allows Kubernetes to scale up the deployment and apply it, right? So instead of V1, now you have V2. But the traffic, everything still goes to the primary, the clone, which is V1.
So I like to make the steps. So first, a canary just exists and it has a deployment reference. And the first thing the canary does, the canary resource does, is makes a clone of the V1 deployment.
Yes. Then it routes all the traffic to that clone.
Then canary then it scales the original one to 0.
Yes.
Okay.
So you can think about this as the initialization of the canary, right? These three steps happen only at the beginning when you create the canary custom resource.
I see, thanks y'all for asking questions. I see your questions. I'm going to finish out what we're going over here, and then we'll tackle those questions. Thank you for asking questions. So these three are the initialization steps. Now the user modifies the Kubernetes deployment. So now we have a V2.
Yes, what I really want to point out here is that it's not only about modifying the deployment. It is about modifying anything that touches your application. Most, incidents in the last years are not around modifying, rolling out a new version of your app.
Uh-huh.
Usually people have, unit testing, maybe some end-to-end tests for the actual app code. What we actually see, like CrowdStrike and I know Google Global Load Balancer around 2 years ago. Most incidents are generated by bad configuration. Not the actual. You don't change the code. You change something in your config and everything blows up.
Yeah.
Right. So what Flagger does is when it sees a deployment, it discovers all the things that are referenced in that deployment. And there are in Kubernetes, there are two ways of passing configuration to your app. One is through config maps, and the other one is through secrets. And config maps and secrets can be mounted as files, can be loaded in the environment as environment variables for your application, and so on. Right? So Flagger also creates a duplicate of everything that makes up your app configuration. So it's not only the deployment which is cloned, it's also any config maps, any secrets, all these objects that are referenced and mounted inside the deployment.
And that's as part of the
Yes.
initialization step. There we go. And all related resources.
Yes. So now maybe you make a change to a config map, maybe you make a change to the deployment spec or to a container version and so on, right? What Flagger does when it sees, so you apply this, but when you apply it, nothing actually happens, right? All the traffic is to the V1, all the users are routed there. When Flagger detects there is a change, maybe in the deployment, maybe in a config map, maybe in a secret, the first thing it does, it scales from 0 the new deployment.
Okay.
Right? Then, if you have also referenced horizontal pod autoscaler, it also clones the horizontal pod autoscaler, as it does with config maps and secrets.
Well,
so when you make a change, then Flagger says scale to 1. When a deployment is scaled to 0, the horizontal pod autoscaler for it pauses. That's a great thing in Kubernetes, right? So Flagger will scale the new deployment to 1 replica, and then it waits. If there is an horizontal pod autoscaler, it waits for the horizontal pod autoscaler to set the minimum replicas it needs to do for that deployment. Then Flagger looks at the usual signals from Kubernetes. Is the deployment healthy? And how it does that, it looks at the probes in the same way that Kubelet does. If the new deployment is successful, it does the rollout, and is running with the minimum replicas set, then Flagger starts to route traffic from the old version to the new version, and you control this, the rollout of the traffic. You can say, every 1 minute, move 1% of the traffic to the new version.
So Flagger spins up a V2 deployment, but it's scaled to 0 initially, right? Okay.
Yes.
And that's when tests are run on V2 while it's scaled to, or minimum number of pods is made, and tests are performed on that to make sure it's healthy.
Yeah, in tests in Flagger are something different.
Okay.
It does a health check if you want.
Uh-huh.
That's a better word for it. It looks at the
Okay.
readiness probes and the leafness probes of Kubernetes. And if the deployment is actually healthy with the minimum number of replicas, then it starts to do the canary analysis logic, which is analysis is a specification inside the canary custom resource where you define how the rollout of the new version should proceed. And you have here many things that you can do. For example, you can run end-to-end tests. You can tell Flagger, hey, run Helm test, for example, for the newly scaled deployment. Or Flagger has its own add-on called load tester, which can do a bunch of things. You can run load tests, it can run arbitrary scripts. It also integrates with end-to-end testing platforms. The idea is after the version 2 of the deployment is healthy, you can instruct Flagger to run some smoke tests, let's say, right? And not trust only the Kubernetes readiness and leafness check, run more advanced things specific to your application. If these prerequisites, let's say, are okay, Flagger runs them, it looks at the result. If everything is fine, then it moves to the second part of the analysis, which is the here there are also various ways on how you can define it. But let's choose canary deployment with progressive traffic shifting. So in progressive traffic shifting, you tell Flagger how much traffic to route from the old version to the new version, which metrics to read after it routes the traffic to make sure the new version is healthy, and gradually move more and more traffic to the new version. Or you can tell Flagger to mirror the traffic. So users never end up to encounter errors with version 2 if there are any. It just mirrors the traffic from version 1 to version 2. Or you can do, as I said, A/B testing based on a cookie or something and segment your users, and only those users with, let's say, a particular location or a particular browser will be routed to the new version.
So I'm going to repeat everything you said to make sure I understand. So we scale up V2 to the minimum amount. We do like some baseline health checks. If those are good, that's when Flagger scales the deployment as defined in the canary object. Is that correct? Or is there an in-between step?
No, so Flagger only scales the deployment to one replica at the beginning. Then it waits for the horizontal pod autoscaler to do dynamic autoscaling. Right?
Okay. So if it's healthy, then the horizontal pod autoscaler scales up the deployment. Is that?
Yeah.
No. Yeah. Okay. But the horizontal pod autoscaler, like with Canary, you're scaling up a little bit, doing some checks, scaling up a little bit, doing some checks, right? So if healthy, the horizontal pod autoscaler scales up a little bit, right?
Yeah, usually, so because there is no traffic, there is no load, there is
no traffic,
no one using the new version,
Okay.
The horizontal pod autoscaler will scale the deployment to the minimum replicas specified in the horizontal pod autoscaler definition, right? Let's say minimum is 3 or 2. It will do 3 replicas.
Uh-huh. So the
Then,
horizontal, okay.
so
The
Flagger waits for the horizontal pod autoscaler to reach the minimum specified replicas. Then it runs the smoke tests that the user has specified in the canary definition.
And will you define a smoke test, please?
Yes. Let's say you have an endpoint that does authentication in your web app or web API. You can tell Flagger, call this endpoint with this test data and look for the HTTP result. If it's, I don't know, 202, move forward, the users can log in. So you don't expose any user to an application that has authentication broken, right?
Mm-hmm.
This is what people refer to testing in production,
Mm-hmm.
right? Because no matter how many end-to-end tests and so on you have in your dev and staging environment, production is different, right? The configuration is different, so it can fail. So Flagger allows you to run this end-to-end test suite, which I call it the smoke test, also in your production environment before users, are routed to the new version.
Mm-hmm. Okay. V2. So HPA scales up V2 to a minimum amount. There's still no traffic, no end user traffic. Then Flagger does V2 smoke tests as defined in the canary, and there's still no traffic. And then what?
Then, based on what you define in your canary, it starts to route traffic to the new version.
Okay.
And here you can say, you can specify a percentage and a time frame. You can say every 5 minutes, route 5% plus 5% to the new version.
And then is there any sort of verification done to make sure as you route more traffic to it, it's working as expected? Is that part automated? Okay.
Yes, so every time you progress, you can tell Flagger to read metrics, and Flagger comes with built-in metrics for HTTP errors and latency. So those are built-in. You can say, oh, if the percentage of the 500 errors is greater than my service level objective, let's say 5%, roll everything back, scale to 0 the canary fails. Right, so, and another built-in metric is latency. If the latency of all the requests are more than 200 milliseconds, fail the canary. And why Flagger comes with these built-in metrics? Because all the ingress controllers and all the service meshes that integrate with Flagger offer by default these two metrics in Prometheus. Istio does it, Linkerd does it, Nginx does it, everybody. So that's why instead of having people to write the Prometheus queries for these two metrics, Flagger allows you just to specify the name, latency, this is the threshold, and it knows how to compile the Prometheus query, to query the Prometheus server, and look for that. But of course, these two metrics are the basic of what you can do with Flagger. You can also have custom metrics. There is a different custom resource that Flagger exposes that you can reference from your canary, and you can write your own Prometheus queries. And yeah, not only Prometheus. Let me look at the list. There is a huge list of things. Yeah, so Datadog, CloudWatch, New Relic, Graphite, Dynatrace, InfluxDB, Google Cloud Monitoring, Stackdriver, and others. Right. So for each of these metric database, you can write custom metrics.
And then does it just keep verifying, moving forward until it's successful? And all the traffic's going to V2?
Not all the traffic. You can say add 5%, make sure all the metrics are in the prescribed thresholds, so you don't break your, as I said, your service level objective. Then when it reaches, let's say, 50%, you are confident that if 50% of the application works okay with 50% of the traffic, you don't need to actually move all the traffic, so then you move it back. What you can say is, at this point, trigger the final step of the release and move from V1 to V2.
Okay.
Right.
I'll put it here.
So when I started Flagger, I implemented this progressive traffic shifting from the primary to the canary, from V1 to V2. And you could say, 5% reaches 50%. And then what happens is that you change the old deployment, you do the usual Kubernetes deployment, and then you move all the traffic back to the new version all of a sudden. And yeah, people started using Flagger. We have huge Flagger users that have, I don't know, tens of thousands of requests per second. And they had a huge issue. The problem was that your horizontal pod autoscaler couldn't keep up. And the application will fail because you move, let's say, 50% gradually from V1 to V2. Then you upgrade the new version to V2, 50% is here, 50% is here. Then Flagger in the past would move everything back in one go, 50% back, and then scale this to 0. And the problem was with huge traffic was the horizontal pod autoscaler for the primary deployment couldn't keep up with moving half of the traffic back all of a sudden.
Okay.
Right? So the primary would fail. And now Flagger also allows you to specify how to do this progressive switch back. You can say move 5% from the old version to the new version, then 10% back. Don't move it all of the sudden, right? So you have control around shifting in one side, then shifting back.
Okay.
But at the beginning, I didn't see that kind of issue because
I couldn't have guessed.
I'm not running this type of applications at scale, right? So it was a miscalculation from my side.
I love that. So we have a few questions in chat that I've been postponing until we had a moment because I wanted to finish this thought before we moved on. But Dinesh says they're using Flagger with their workloads to manage canary deployments. They're looking for guidance on how to handle scenarios where Prometheus metrics used by Flagger for decision making, like we talked about, become temporarily unavailable. So has anyone implemented specific mechanisms to handle when your observability backend that you're referencing to define success, to reference when that observability backend becomes unavailable?
So Flag already covers this. There is a threshold, a threshold for errors. You can tell Flagger, hey, tolerate some errors. Even if, this metric reading fails, don't do the rollback. And you can say the threshold, like, if it fails 5 times, then roll it back, right? So you should be looking into setting a higher threshold if your Prometheus backend goes offline. That's not good if the Prometheus backend goes offline, but anyway, there is error toleration, right? Nothing goes perfectly. So there are these thresholds for metrics reading, for running end-to-end tests. Basically, everything in Flagger you have some means of saying retry this. Don't give up for the first try.
That's a great answer and a great question. Thank you, Dinesh. This question is about Argo rollouts. We'll talk it out. So when I was reading about both Flagger and Argo rollouts, I can see Argo rollouts can do canary deployment strategy by doing a basic level of predefined gradual traffic shifting defined in their rollout without the L7 tool being necessary. How is that possible for Argo rollouts to do that, but not by Flagger? Pardon me if I'm missing something. I think I might know the answer to that. Within Argo rollouts, so you have a rollout resource that replaces the Kubernetes deployment. So you're not using a Kubernetes deployment resource at all. And so a Kubernetes deployment can manage a replica set and pods. But this new rollout resource that Argo rollouts introduces, it also creates services. So you have a preview service in I forget what the old service is called, but you have 2 different services, and it's able to move the traffic between Kubernetes services. And then a reason you might want to choose Flagger instead of Argo rollouts is exactly to do with that same way it works, because maybe because you're so dependent on Kubernetes deployments that you already are using in your system, you don't want to switch to using a different type of custom resource to define your applications. How is
also
that?
Flagger,
Yeah,
but that's not the reason why Argo can do progressive traffic shift. Also, Flagger creates two services, but it's not about services.
Okay.
So because Argo replaces the replica set controller, the native replica set controller in Kubernetes, they replace that with their own thing, which is Argo rollout. So how they are shifting traffic is based on the number of pods. So if you have 10 pods, right, and it replaces one, then that percent of the traffic goes to the new version. Right? It's the same stuff that Kubernetes does. So you can split the traffic based on the number of replicas. But imagine doing 1% gradually. You need 100 pods.
Yeah.
Right? I'm not sure anybody actually uses Argo rollouts without layer 7.
L7. Yeah.
Feels quite challenging to spin up that amount of pods to have a fine-grained control over the amount of traffic. If you, I don't know, are okay with, the canary, the first instance, 50% goes to the new version, then yes, you spin up you have two pods, you replace one, then 50% goes to the new version, right? Anyway, also Kubernetes does that on its own.
Yeah, it does do that on its own. And then our next question is, can Flagger somehow monitor error logs from pods?
Error logs from pods. It can if you expose the error logs as a metric.
Yeah.
Of course, Flagger will never exec into a pod and look at all the logs and parse the logs. But there are so many projects into CNCF who can actually do that. There are all the projects which are around log aggregation, right? They can look at logs and expose a Prometheus metric. Then Prometheus will scrape the log aggregator and to see, oh, from 100 logs, 50% are errors, and if it exposes that to Flagger, then you can create a metric template. That's the custom resource called in Flagger, when you can write a Prometheus query and look at that particular metric, or Dynatrace, or CloudWatch, or whatever you use. Flagger actually works with a bunch of stuff. So no matter what monitoring solution you have, as long as you are able to convert logs to metrics, that can be queried by Flagger. There is one thing on this slide. There is this way of creating a metric template and query some metric database. But Flagger also has this system of webhooks. It can call your custom-made system. That system does a particular logic inside, and if it responds to Flagger with a 500 error, then Flagger counts that as a failure of the canary, right, with the threshold and so on. But there are a lot of Flagger users which have their own custom monitoring tools. And Flagger will call in those tools. And when Flagger calls the tool, it sends the canary name, the deployment name, the namespace. So that tool can actually identify, oh, Flagger wants a response for this particular application. And if it's pure HTTP thing. If you respond with 200, then Flagger will move with the progression. If you respond with 500, it will pause. If you respond with errors continuously, it will roll back. So if you have, I've seen integrations like a couple of KubeCons ago, someone had a talk around Flagger will call into Jenkins. Jenkins will run the end-to-end test, then respond to Flagger. Yes, the end-to-end test has passed. You can move forward with the rollout. The idea is that I didn't want to put in Flagger all this logic, right? It's impossible to write every single procedure of testing an app. So webhooks are a way of how Flagger can reach out to your very custom tool or whatever you already have in your infrastructure and integrate it with that.
And so I would like to list all the different ways Flagger can verify that a deployment was successful. Will you list them for me again?
Yeah, so the basic one is it reads HTTP metrics, and that's effortless. You just say it reads HTTP errors and HTTP latency. So these are the built-in checks, work across any ingress controller and service mesh. That's the least you can do, is set up these metrics. Then you can extend the metrics checks with your custom queries. And the query, you put these queries in a metric template. So if the built-in metrics are not enough, you should create metric templates. And through the metric templates, Flagger integrates with all the metrics provider that I talked about, Prometheus, CloudWatch, Datadog, and so on.
So you can do metrics check with a metrics template custom resource. which integrates with a lot of different observability backends.
Yes.
Are there others?
Then you have a thing called webhooks. And you
Okay.
can configure Flagger to call out to an HTTP endpoint. And from there, you are responsible to return success or error. And you can use these webhooks at different stages in the rollout. There is a confirm rollout webhook, pre-rollout webhook, confirm traffic increase webhook, confirm
Okay.
promotion, post-rollout, rollback, and so on. So at every step that Flagger performs, you can add a webhook and say, oh, don't do the full rollout. Some human needs to approve it, right?
Okay.
You have QA testers, and they need to do some manual things or whatever. Some human has to say, yes, the new version is good to go, right? So this is a confirm promotion webhook. You call your custom endpoint, people integrate here with Jira and other tools like that. When people say, yes, I really want for this new version to go forward. And you can ask permission before the rollout starts, while the analysis runs, or just before the rollout is completely deployed.
Cool. We have another question. I really appreciate all the questions, y'all. This person says, new to Flagger, but not new to Flux. How would Flagger work with a database migration as an init container?
Oh yeah, good question. Yeah, stateful sets are a pain, right? There is no tool out there that will save you from the stateful set management. The answer is simple. You should always do database migrations in a way that is backwards compatible. And there are various ways. There are like books written on how you do good database migrations. For example, if let's say you do a database migration from an init container and your new version looks at a new column in the table, it needs to add a new column. Let's say you have address as a column right now, and you want to have city and I don't know, country, postal code, whatever. So you want to split the address column into multiple columns. Now, if you are new to this stuff, you would say, all of a sudden, I'm doing the transformation and I'm dropping the address column because now I have all these new columns and the version of this app knows how to query all these new columns. That will never work in a progressive delivery deployment because the old version and the new version are running in parallel. What happens if maybe the new version, crashes or the metrics are not good and so on, rolls back? The database migration has already run, so now you are completely stuck, right? Both versions will fail. So how you do that? You never drop tables or columns in tables in the first time you write the migration. So you write the migration, you don't drop the address column. So version 1 will still work. Version 2 will look at the new columns. And then when you deploy version 3, in that
then
migration, you say
drop version 1 column.
Then you can drop, right? So yeah, there is no tool out there that can make this automatically. you need to think about when you do alteration of your database, you need to think about, will I always run two versions of my app in parallel? And even if you're not using Flagger or Argo rollouts or whatever other tool that does progressive delivery, even if you are doing a simple Kubernetes deployment, if it's not a strategy replace, if it's the default rollout procedure, you'll still run two versions of your app in parallel, right? So you'll still run into this issue, but maybe you'll not see that often because it goes very fast, right? With progressive delivery, the idea is you don't roll out very fast because you want to collect metrics. So it should take time in order to make a good decision. Is this new version reliable, right? That's why I'm referring to Flagger more about like, there is this concept of no deploy Fridays and the fear of breaking production. Everybody has broken production at least once in their lifetime, right? And the idea of progressive delivery is to take that fear away. The idea is that you can deploy on a Friday, you can deploy 5 minutes before you are leaving or home because you have a tool like Flagger that looks at signals, and if your new version is not good, it will roll back. Maybe 1% of your traffic is impacted for a short period of time, 1% of your users. And you go Monday back to work, you see the Flagger alert on Slack, or it integrates with Slack, Microsoft Teams, a bunch of, Rocket, bunch of chat solutions, or how you want to call it, PagerDuty and others, right? You see the error, and your users didn't turn out over the weekend and got the application broken because the moment Flagger sees an error, it will roll it back. So in a way, it gives developers confidence into you should be comfortable with making mistakes, right? In order to have a fast delivery, and that's the promise of continuous delivery. We ship fast, right? We don't do a release every year or every half a year, right? In order to be competitive on the market, you have to ship features fast. And continuous delivery achieves that, right? It's very easy with some GitHub Actions and Flux, right? You commit something, GitHub Actions builds the app, Flux deploys it, but deploys it to everybody, right? So you need to be really careful. You have now this continuous delivery system in place, but the fear grows because every time you do a commit, oh damn, it will end up in production in 5 minutes if I'm doing something wrong here. My boss will chase me. Now, Flagger is at the end of the pipeline, after Flux, after Argo, where it's basically saying, no, I'm not going to allow this new version to be exposed to everybody. And it has all these guardrails in place to, protect you from mistakes. And you'll always do some mistakes. So that's the gist of it.
It's not, don't just count on the mistakes and plan for them, right? I have some questions. Why is a clone made of V1? What's the point of that?
GitOps. So the design of Flagger, when I designed Flagger, the idea was Flux looks at the Git repo where the deployment is. If you change something in the deployment in Git, Flux overrides it in the cluster. If you change the deployment in the cluster, Flux will detect a drift. It's right. The desired state has the actual state has drifted from the desired state, and it will correct that drift. So if Flagger will modify the actual deployment, then Flux will undo all the changes. So that's why Flagger needs to create this clone, which is Flux doesn't see it, Jenkins or whatever, Helm, whatever tool you are using for deployment is not aware that oh, there is a clone of my deployment which runs, and that's where the traffic goes, right? So basically, having this clone, I didn't have to re-implement the deployment controller, make people replace the Kubernetes deployment with a custom resource like Arborolot. My solution to be compatible with GitOps and any other deploy tool out there was to create this clone, which is fully managed by Flagger, and it will never conflict with whatever you have in Git or whatever you have in your Helm charts and so on. This also allows you to adopt Flagger for applications that are already in production, right?
So then, it's like a workaround for drift detection, for Flux's drift detection, right? It's a workaround so Flux doesn't see the new deployment as a drift.
I wouldn't call it a workaround. It's a deployment strategy, because this is how so the desired state is the deployment scale to 0, right? That's what Flux changes. And then it's mentally is the separation between deployment and release, right? People think of deployment and release are the same thing. Well, they aren't the same thing. You do the deployment, but that doesn't imply also a release. This is what Flagger does, right? So you do the deployment, the new version is there, but that doesn't mean it's actually released to the end user. The release procedure takes part with, all the things that I've explained with with this clone of the deployment. So it basically splits the deployment from the release procedure.
And then, so then when everything's done and it's all rolled out and all the traffic's going to V2, do you then, if you're using GitOps, do you then go into your Git repo and redefine the desired state to have your deployment as V2?
No, the desired state is already V2.
Oh, okay. That's how it starts. Oh, because what GitOps wants to do is get rid of V1 altogether. And so you need a clone so that when GitOps gets rid of V1, I see now. Okay.
Yeah. So in the desired state in your Git repo, you have V1 there. Then you say, okay, I have to do a change, and you commit the change. So now in Git, there is V2. Flux applies V2 on the cluster, but V2 is not released yet. It's just applied, because the release is the clone. And then Flagger decides if V2 should be promoted to all users, should be actually released, or just scale to 0, it fails, and then it alerts you somehow. And of course, you have when Flagger does a rollback, when let's say it stops the V2 from moving complete to production because let's say a metric fails or an end-to-end test fails, then you have a drift between the desired state, which is V2, and V1, which is running in your cluster. This should be treated as a production incident. Yeah, my deployment failed. Okay, users are not affected, but it's still an incident, right? The new version has failed. The problem is not that urgent because, as I said, you can do it on a Friday and you can fix it on Monday because users are not impacted. If you don't have this type of advanced rollout, then you have to fix it on a Friday. You have to be there to roll it back in Git so it rolls back in production and so on, right?
That makes a ton of sense. And so then we rolled out slowly from V1 to V2 using a canary. And now we have all the traffic at V2, and we have for a while. So we don't need V1 running anymore. What do you do then?
then Flagger scales to 0 the deployment which is controlled by Flux. And
Okay.
the trick here is,
Mm-hmm.
how does that work? Why isn't Flux scaling back the deployment? You don't actually specify a replica in your deployment YAML.
Mm-hmm.
You specify min and max replica in your horizontal pod autoscaler
Ah.
definition. And the horizontal pod autoscaler controller, when it sees that the target deployment scales to 0, it pauses.
Uh-huh.
That's a thing implemented in, I think, Kubernetes 1.2 or 1.3, because it was a big problem at the beginning with Flutter, but I think it was already implemented in HPA V1 Beta 1 or Alpha 1 or something like that. I forgot, many years ago. But that was the trick. Like, the HPA pauses when a replica is set to 0, so Flagger is fine to scale that deployment, so it doesn't consume resources for nothing, because traffic is no longer goes there.
So then
Uh,
do all the old versions of your app, the definitions kind of accumulate over time? They're never
no,
really deleted? No.
no, because you override the new version every time, right? You have
Okay.
one deployment YAML in your Git repo. All the versions are in your Git
Uh-huh.
history. That's why you do GitOps. In the
Uh-huh.
cluster, if you do kubectl get deployments, you'll see only 2 deployments all the time. The primary one, the clone, where all the traffic goes, and the one that you have in your Git repo. So you don't accumulate versions, you only have the last version in your cluster twice. One is scaled to 0, one is scaled for the traffic that it receives.
Okay, so like we have V1 and then V1 is, and it's referenced in the canary deployment, so therefore there's a V1 clone. And then anything changes, so then we have a V2. And then based on this whole process, traffic slowly gets moved from V1 to V2. And eventually this V2 has 100% of the traffic. So now V2 is the only one we care about. Now, at what point does V1 go away? Because we only need V2 and then presumably a V2 clone eventually gets made, right?
Yes.
So like what's the process of being like, okay, I don't need V1 anymore. It's gone.
So in the canary custom resource, you specify the amount of traffic that you want to move to the canary version
Uh-huh.
until you declare it ready. Okay, it's great.
Oh, so
This is the version I want.
this
Right?
final
You said
step.
there 100. Yeah.
So
So
as
in
part
the
of this
final
final
step,
step, that's when we're saying goodbye to V1, any sort of V1 running anywhere. Got it.
yes, yes.
And does that final step also clone V2?
So final step is when all the traffic is on the canary version,
Mm-hmm.
what Flagger does, it tells Kubernetes now roll out V2 over the clone. And Kubernetes does its own usual Kubernetes deployment. It
Mm-hmm.
replaces the old clone with version 2. Then Flagger can slowly move the traffic from the canary to V2. So from the same version to the same version now. And I said at the beginning why it needs to move slowly and not all of the
Uh-huh.
sudden, because if you have crazy amount of traffic, the clone is maybe 1 replica or 2 replicas, and it needs to be at 100 replicas to take over all the traffic. So it gives time to the horizontal pod autoscaler to adjust.
Okay. All right. I think I understand. And then I have another question. So we made a bit of an assumption. So we talked about canary deployments where things slowly go from one to another. And you've also mentioned A/B deployments, which I'm honestly less familiar with. And there's also blue-green deployment. Is blue-green the same as A/B? Slightly different? They feel the
No.
yeah.
So
Blue-green
in
deployment.
a
Yeah. And I'll
so in
talk
a
about
blue-green
blue-green.
deployment.
Yeah.
Okay.
I'll try to say blue-green deployment and you can tell me if I have it right. And then maybe you can please teach me what A/B is. So in the blue-green deployment, the blue deployment is, this is the older one. So this is the V1. And then we want a V2 and all the traffic is going to V1, 100%. And then we want to run V2. So then that's our green deployment is V2. And right now, no traffic is going to it, but it's running alongside blue. And then while there's zero traffic going to it, we can do a lot. We can test it a lot. And what's common, test. And what's common here is to mirror the traffic. So there's the production traffic, a ghost version is going over here. So you can test it against the production traffic, but no actual users are seeing it. And then once it feels good and you feel secure about it and it's tested, then bam, all of a sudden you send 100% of traffic now to the one that's ready to go. But you keep the blue running just in case it's not, something goes wrong, you can switch it back to blue. Is that correct?
Yes, but the mirroring is, I think,
Optional.
less than 1% of all the apps out there supports mirroring. And the
Okay.
explanation is quite simple. Most applications are not stateless. They do something with the database, with the cache, with some files. So let's say your app does, I don't know, credit card transactions. If you mirror the traffic, when someone pays $10, they will pay 20, right?
Okay.
No one will do that, right? Basically, no application that is not for reporting, which is not read-only, can support mirroring. Mirroring is an extreme case, in my opinion. Like, I don't know, machine learning models. Those are great for mirroring, right? You want to run the same, I don't know, question on both of them, and you can actually mirror traffic and do that. Why? Because it doesn't write anything. It doesn't store the state. It just responds with data. But any other application that does something with a database or does transactions to some other external system, mirroring is not actually an option. So usually a blue-green deployment means you spin up V2, you run your end-to-end tests, you hope that everything is fine, and you move everything right to V2. And yes, you keep V1 around in case everything fails. And you move back. And Flagger can actually do this type of thing without any layer 7. So Flagger does blue-green deployments with the Kubernetes CNI. It's fine. If you want to do this type of deployment, you can actually do it with Flagger. The advantage is you can still use the Flagger webhooks to run your end-to-end tests. You can use the Flagger metrics to decide if the new version is fine or not. And also Flagger supports blue-green with mirroring, like you said. And as I said, it only works for apps that are, let's say, that they don't change any state.
Okay, and can do without layer 7 and only works for apps, or the mirroring only works for apps that don't do state. But in general, you can do blue-green with apps that don't do state. Okay.
Yes.
And
so it's blue-green and blue-green mirroring, which in my mind is a totally different deployment strategy.
Okay. Okay. So this is what I'm going to do. So besides well, I'll just leave canary. So strategies. So first of
Yeah.
all, definitely canary, which is what we've talked about a lot.
No, let's put first blue-green. Let's start with the easiest one and go to the most complicated one. So
Okay.
the easiest one, which requires no ingress or service mesh, no layer 7, is classical blue-green.
Basic blue-green. No
Then,
L7 needed.
yeah,
And then blue-green mirroring with L7 and no state.
yes.
Needs L7. App can't have state. And then is AB next?
Yes.
What is AB?
AB is pure traffic splitting. Nothing progressive about it. You say, so it's blue-green, but instead of routing all the traffic all of a sudden, you say, I'm routing to the new version a segment of my users. And a segment can be a location, something in the cookie, something in an HTTP header. You can say, as I mentioned before, you can say mobile users go to B, or users from that
Oh,
particular location, and so on.
so some characteristic of the traffic is the thing that's being used to route between the versions.
Yeah.
As opposed to canary, where it just has to do with like a percentage of all traffic. Is that correct?
Yes. So A/B deployment implies traffic routing based on headers/cookies. Cookies are headers. So yeah. But the cookie thing is quite powerful. How people are actually using A/B with Flagger, they inject custom cookies. For example, you have an insider program where you give some benefits to your users, some, I don't know, price discounts or
Oh.
whatever, and they apply to the insider program.
Uh-huh.
You give them these benefits. Then you inject at login a cookie where it says insider. Then when you deploy a new version, you tell Flagger, route all the users with the cookie insider to the new version and use them as testers. Right?
Oh, okay. So
So
the goal is still to get from one to the other. We're not having two versions running indefinitely. What we
no,
just
not indefinitely.
we're using our most loyal customers as guinea pigs because they're less likely to get mad at us if something goes wrong.
Yeah. Or you do, I don't know, if you are Facebook uses, for example, your age. Say, oh, we are testing the new version on, younger users, which have more tolerance to failures, whatever. You can come up with any kind of segmentation, and you can write that segmentation in a cookie. Then
Okay.
with Flagger, you can tell Flagger, look at the cookie, and based on that value, use this as a guinea pig or not.
Uh-huh.
Right? So that's how A/B test works in Flagger. Now you have canary deployment with progressive traffic switching.
And that's what we detailed here.
Yes.
And do these different
There is another one.
Oh, okay.
Last one.
Yes.
But
And
there is.
Do these different strategies each have their own custom resource, like this canary custom resource? No, the canary custom resource is what supports all of these strategies. Okay.
Yes.
Uh-huh.
in the analysis section of the canary definition, you can switch between all these versions. But there is also a last strategy, which is a little bit more complex, but I will explain why it is useful. It's canary deployment with traffic switching and session affinity.
Ah.
So it's progressive traffic switching with session affinity. And why? What does it mean? Why would you even need that? So let's take what we discussed so far with canary deployment with progressive traffic switching, the default one, right?
Uh-huh.
How this works at the layer 7 implementation. How do you say 5% of the traffic goes to the new version? You have a total of TCP connections, right? And you take random 5% of all the connections and you switch them, you move them to the new version. Now, a normal user, if it accesses a web app, it has more than one connection.
Oh,
A browser
yeah.
opens maybe. You have a connection to download the HTML file, another connection to download the CSS file.
Yep.
So what happens when you do progressive traffic switching? You'll get the HTML from the new version, and by chance, you can get the CSS from the old version. Everything will be broken. Right?
Yeah.
So canary deployments do not actually work for front-end apps. It works for front-end APIs. For example, if you do what's the best case of doing this? You have a API, let's say mobile API, you have the mobile app, and when the app does a request, you forward the request to the new version, and that works fine. But for a web app where you also pull your interface from the server, you'll end up with mixed things, right? So what's the solution to this? How you can do something progressive for
session affinity, which you just taught me. I didn't actually know that before today and right now. So session affinity is that it keeps track of the user's session and makes sure that they're always going to the same version of the app for the whole time there.
Yeah.
And how long does this session usually last?
How technically how it works is Flagger instructs the ingress or the proxy, the layer 7 proxy, to add a cookie to the first HTTP response.
Okay.
So you end up on the new version, and then you get a cookie. Oh, you are on V2. The second request you'll make, that's the magic of cookies, it will be attached to the second request. Then the rule in the load balancer is, if it has the V2 in the cookie, always route it to V2. So once a user ends up on the new version, they stick to it. That's why it's called sticky.
So it only has a V2 cookie. It doesn't have a V1 cookie.
Yeah, only V2. That's what you care, right? Once it ends up there, stay on the new version. You don't want to get the CSS or whatever, the HTML of the old version, so they mixed up, right?
Okay.
And then at the end, when Flagger does the final rollout, the cookie gets deleted and everybody is back to normal. And this does not work with Linkerd, for example. Linkerd has no such implementation. Can't inject cookies. Session affinity works with Istio and some implementation of the gateway API. Not all ingress controllers are capable of injecting cookies, right? So it's not about Flagger has all these capabilities, but you also need
The
the
network
underlying
technology.
layer 7, to support all of that, mirroring, right? Not every single ingress controller out there supports mirroring. I mean, I think only 2 of them support it and so on. This cookie injection is also quite niche. So
Okay.
yeah, it's not only about Flagger. You also need the layer 7 to have all these capabilities to implement all these deployment strategies.
So you want one with mirroring is more niche, and you want one with cookie injection.
Yep.
We have filled the board, friend. Do you have more that you wanted to, did you feel like we covered everything pretty well, or do you feel like there's more you want to say, even if we can't write it down?
I'll let others discover Flagger. It has a bunch of things. In 6 years, there were so many features added, not by me. I think that's the beauty of open source. I started the thing with Istio and Linkerd, then it's all about external contributions. Like the last years of Flagger, expansion was made by users that they liked Flagger, they liked the idea, but it didn't support the service mesh they were using, Kuma, for example, right, from
Yeah.
Concord. And they asked the service mesh maintainers, hey, can you contribute the integration to Flagger so we can use Flagger with your service? And that's how Flagger evolved. I think the biggest first contribution was made by the Solo IO team, and I implemented Nginx ingress. It was the only ingress supported back then. They were, having this crazy ingress based on a crazy thing, Envoy. No one knew about it. It was very, very new, right? And that was like 5 years ago. And they had the biggest ever contribution to Flagger. They implemented a different ingress controller. And afterwards, I kind of try to evolve the Flagger code in a way that's very easy to add a new integration. You just implement some interfaces, and if you know what your service mesh is doing, it's very easy to add that integration to Flagger. And that's why there are so many integrations I don't even know by heart all of them.
Yeah. That's the best. So to wrap this up, I'm going to recap everything that you've taught me today, repeat it back to you, and if there's anything I don't have correct, you can clarify it to make sure we have a good board. So let's do this thing. All right. So before Flagger, it's funny, I always ask someone, like, what was the world like before Flagger existed? Like, what caused it to get made? And today I could ask, what caused you to make it? So I got like a much more personal story than I usually do, which I really liked. So you told a story of the demo you did at KubeCon, where you were integrating Flux and Istio, and how cool it was to split traffic between versions. And people were like, hey, maybe we could, this is a difficult and manual process, maybe we could automate this. And that's how the idea for Flagger was born. And it was called Steerer at first?
Yes, Steerer, yeah.
Which is fun too. And then progressive delivery is a term that refers to advanced deployment on Kubernetes and basically makes deployment safer. And we're going to go over more specifically what some different progressive delivery strategies are. And then another piece of context that really helps going into this conversation about Flagger is to talk about dynamically routing traffic and doing fine-grained routing. You need some sort of networking technology that does layer 7, which is that supports traffic protocols that do more fine-grained routing because it has extra information in that protocol that you can use to route. So specifically, if you want to take full advantage of Flagger's capabilities, you want to add a L7 layer that does mirroring and cookie injection, like Istio, you said, is a good one for that. So now we're talking about Flagger. Flagger is a progressive delivery controller for Kubernetes, and it's a deployment orchestrator. So since the other big tool in the space is Argo rollouts, and it makes a whole different Kubernetes resource, and Flagger does not do that. Like Argo rollouts has a different resource instead of a Kubernetes deployment. Flagger works with the Kubernetes deployment resource. I'm going to skip that for now. So there's one main, I'm sure plenty of Flagger custom resources, but the one main one where you define your advanced deployment strategy is called a canary resource. So you said it resembles a horizontal pod autoscaler, and it points to one Kubernetes deployment or a horizontal pod autoscaler. So then we go through some steps. When you make a new canary resource and you point it out a Kubernetes, a version that you want to deploy, we'll say V1. The first thing it's going to do is it's going to make a clone of V1 and all of the resources that touch V1. So any horizontal pod autoscalers, config map secrets, any other tangential resources. And it does that because of GitOps, because if you modify V1 inside, it's actually, GitOps has V2 defined. So GitOps wants to delete V1. And so you make a clone. So when GitOps deletes V1, you still have V1, basically.
Does not delete, let's say, when it replaces.
Replaces V1 with V2. You still have a V1. Got it. I like that. And so that's why a clone is made. And then the canary routes all the traffic to the clone. Now the canary scales the original clone to 0, and that is all the initialization step to prepare for the initial one to get changed to V2 by GitOps. So now the user modifies the deployment, and anything that touches the deployment, that makes GitOps, that makes the V2 be created. And then Flagger spins up V2, but it keeps it scaled to 0. Then the HPA scales the V2 up to the minimum amount of pods that you've defined in your HPA. Yes.
No, Flagger scales from 0 to 1. You can't
Flagger
scale
spins
to
up
0.
V2s. That makes more sense. And then the HPA gets in and might scale it further.
Yes.
And then HPA will scale it further, but there's still no traffic going to it. So we're just getting it ready. So, and then while there's still no traffic going to it, Flagger will do smoke tests on V2. And the smoke test it does is what you define in the canary object, and still no traffic. But once these smoke tests are done, now we're ready for our V2 to receive some traffic. So Flagger starts to route some of the traffic to V2. You specify the amount, the percent of traffic, and the time frame you want it to go. And again, that's part of your canary, what you're defining in your canary. And then it's going to do some sort of checks for success or failure. So there are a few different ways Flagger can verify success. You could do it with built-in, it reads HTTP errors and HTTP latency. So that's the basic level. You could also use a metrics template custom resource to integrate it with lots of different observability backends, and then you can pull more advanced metrics about what's successful and what's not. And then also you can use highly customizable webhooks, and you can use the webhooks at a lot of different points in this process to make sure that you're querying something and make sure it's returning a successful condition for you. So so each time it routes traffic, it's a percentage, it's a time frame, and then it's also making sure it's successful. And then when it's successful, it'll route a little more traffic to it. So slowly but surely, it's routing traffic from V1 and V2 and using and verifying success. And then once it's verified and the traffic slowly creeped up to 100%, the final step is to move all from V1 to V2 and to let the V1 version to delete the v1 clone that we created as part of the initialization step. And I
It
think
doesn't delete anything. It scales it to 0, right? It's not a deletion.
Okay.
Because if it would have deleted, then Flux will replace it, right? It can't delete anything. So it's scaled to 0. That's after a successful motion or a rollback. Rollback, it's also scaled to 0. It routes traffic to the old version, scales to 0 the new one.
Cool. What I guess I just don't understand, because in Flux now we have a v2 only, right? In the Git repository, we have a v2 only.
Yeah.
And then there's a v1 clone, and that's what we're using to run. So
the v1 clone is replaced with v2. And the v2 managed by Flux is scaled to 0 because no more traffic goes to there anymore.
Okay, got it. v1. I'm not gonna, I think it's not quite clicking, and it's probably not worth writing down because it's getting into the nitty gritty. So I'll just leave it with the final step is all the traffic moves from v1 to v2, and it matches what's in the Git repo. How about that?
Yes.
That's all we need to know. And then, so one other thing is talking about user modifying the deployment and anything that touches the deployment. That's an interesting piece of the puzzle because most incidents happen from bad configuration. So finally, this is called a canary resource, but it actually supports, we talked about 5 different deployment strategies that it supports, progressive delivery strategies. So it can do a basic blue-green deployment where the blue is the old version, green is the new version, and it switches traffic from one to the other after testing green. For a basic blue-green deployment, you don't need an L7 technology. It does blue-green mirroring, where you do use an L7 technology to mirror all production traffic to the green version before you switch traffic to it, and you can test it as such. But the caveat there is the application can't have state because the state would get messed up by the doubled traffic. Then we have A/B deployment. With an A/B deployment, I learned this today, some characteristic of the traffic headers and cookies is used to route traffic between versions. So you might say, you use the example where Facebook wants to only route young people to the new version of their app because they want to see if the young people like it. They know they have the old folks hooked. You said it differently. Yeah. I may have added some color. Then another version is a canary deployment, and canary deployment is what we've described here, progressive traffic splitting, where a little teeny bit more traffic is added, then it's tested, then a little more traffic is added, then it's tested. But the limitation of this is each time the same user visits a website, that counts as a different visit to that website. And if the same user is getting an experience where sometimes they're saying v1 and sometimes they're saying v2 and stuff's being cached in their browser, it can break their experience. It wouldn't work in a more complex application. So there's a 5th kind, that's canary deployment with session affinity, and that's where Flagger adds a cookie. So then when the same user comes back, they know to keep going to the same version. Or you said whenever they hit v2, they'll keep going to v2 because a v2 cookie's been added to their browser. And that's why, so the mirroring, why you want L7 that does mirroring is so you could do the blue-green mirroring advanced deployment. Why you might want to add L7 that does cookie injection is so that you can do your canary deployments with session affinity. And that's everything. That's what we talked about. Kudos to you. I think that's a wrap. If someone has more questions, if they're watching the recording, where should they go to ask those questions?
So there is a Flagger channel in the CNCF Slack.
Awesome. I'm going, you gave me a GitHub link with a Flagger. What's
Yes,
that?
and you can ask questions also in GitHub. You can open issues and so on. I think it's in a way it's better than Slack because Slack is gets lost in time. Other people can search it and benefit from that particular answer.
Oh, that's nice.
And there is, so yeah, for questions is Slack and GitHub, and we also have a dedicated documentation website with examples for every single service mesh, with guides on how to install it, how to set it up, how to test rollback, how you simulate errors and make sure that yes, it actually does a rollback, right? That's quite important. And yeah, other guides on how you can integrate Flagger, I don't know, with the Prometheus, that you don't run it on your own. All the clouds now have a Prometheus SaaS, right? So it's about authentication and so on. So there are lots of guides and tutorials there around making sure Flagger fits in your infrastructure with your particular L7 monitoring, everything that you run in there.
Amazing. Well, this has been, is Flagger CNCF graduated project?
Yes, Flagger is under the Flux CD organization, and it's a graduate project along with Flux.
Amazing. Well, thank you.
What I want to say is that Flagger is not a Flux only project. There are many Flagger users which use Flagger with Argo, with Jenkins X, with whatever. So it is under the Flux organization. It's built with a GitOps mindset. It integrates very well with Flux and any other deployment tool out there. It's not a Flux only thing. So yeah, we have lots of users which are running Helm upgrade from CI and they still use Flagger to have safe deployments. So you don't even need to buy into the GitOps thing to use Flagger.
Amazing. That's really good to clarify. I appreciate you so much. Thank you for sharing your time and your expertise. I'm going to replay our intro music to say goodbye. And also, thank you for the kind words, those of you in chat. I'm looking at you, Martin, for saying that you enjoyed the show. Thanks for being here. And thanks, Stefan, for sharing your expertise. And
thank you.
Thank you. And thanks to those who watch the recording. I appreciate you.